So what we are going to discuss today is more on data frame side, because as I said earlier, data frame is something which we'll be using very extensively going ahead in our coming sessions, and in real life as well. When you start working and you go to a internship or you go to a project, okay, so you guys will get involved a lot into data frame. Okay, so keeping that in context, so our discussion for today, or rather like the agenda for today's discussion, will be more on subsetting side. Subsetting side, I mean, like how do you subset data frame, okay, and how do you use basics are default function. So there, as I said earlier, that we have a lot of basics function by default functions that R provides. So we'll see how do we use the basics R function. Okay, and then we'll see, like since our data sets will be huge sometime and you need some complex logics, so how do we use packages, okay, like dplyr is something very famous, okay, and very useful, and it's very commonly used in industry. Okay, so how do we use dplyr so to filter the data and subset the data? Okay, so this all comes under the data wrangling thing. That's why I have named this session a data wrangling session. So how do you like wrangle data? How do you clear data, clean data? So all these things come under data wrangling. Okay, so our discussion, like today's agenda, will be dplyr and subsetting a lot. Okay, and we have covered dates function as well in the last session. So there are a couple more examples that I have noted down, okay, which I want to cover, and like keeping the same codes in place. We'll see that if you want, okay, we're taking some more examples and we'll see dates. Fine. So before we go ahead, guys, so like let me know if you have any doubts that you want, or anything more, any concept that you want some more clarification from previous sessions. Please point it out, okay, so that I can take it ahead. Is there anything, or shall we start? Okay, so fine. So yeah, so guys, before we go on this dplyr and data wrangling, so there is something which I was going through, which I missed in like when I talked about vectors, okay, and that was sort. We have seen sort, right? We have seen order as well, if I'm not wrong, okay, and we have not seen rank. So these were few functions which are very useful. So as far as I remember, we have used sort in examples, with examples, and I've explained you. So order and rank, so there is something, this is something which we missed somehow. So quickly I'll just take you through what it is. So let me create a vector called x, okay, and how do we create a vector? We write C and we give any number, 10, 20, 30, okay, then again 10, let's say 5, 12, okay, and then 15. So this is my vector. I create it, okay. So how my x looks like this. So I have 10, 25. So it's a mix and mixture, okay. So now if I sort it, so if I use sort command, sort x, so what it does is it simply sorts it, okay, in ascending order, like starting from smallest number, it takes to the largest number. This is what sort does, okay. Now, like if you do, like order is something which we can see, which we'll use, which is useful, okay. So what it does is basically order gives you, so order gives you the indices, it orders the indices, right? So basically what sort gives you, sort gives you the element wise ascending order, but in which place 5 was earlier, okay. So 5 was earlier in the fourth place, okay, that comes first, okay. So basically it, in the same sequence where which you get the numbers here, the same sequence, the index is getting displayed in order command, order function, okay. So if you want to see the order, if you see the indices in order, so you'll use order command, Okay, so it's a little confusing. So just put in your mind here and think about it. Okay, how it is being. So take this example. So this was my original vector. Okay, what I did is I did a sort. So I got this as output. Okay, so what is this? 5 is my first element, 10 is my second element, 12 is my third, 15 is my fourth, 20 is my fifth, and my 30 is my sixth element. But 5 was originally in what place? It was in fourth place, right? So count it 1, 2, 3, 4, right? So 10 was in which place? 10 was in first place. Okay, so your fourth followed by 1. And then 12 was in which place? 12 was in fifth place. So you have 4, 1, then fifth. So likewise, this is what is getting displayed when you type order. Okay, it is very useful when you work in data frame. That's the reason I'm trying to like make you understand this. Okay, now there's another function which comes into picture, that is called rank. So what rank does is, rank does, like in ascending order, it gives rank to each element of your vector or a data frame or a like list, whatever. It assigns a unique number to each element of the object. Okay, so that, like, first we'll sort it internally and then we'll assign it. So this will like this is your element. Okay, so it will sort it. I mean, it will assign 1, 2, 3 based on your sorting. So now just run rank and check it. How does it look? Okay, wrong. Rank X, rank X. So now have a look. So what it is doing, it is like assigning numbers. Okay, so 10 is your second element, right? Like 10 has first it sorts it and then it ranks it. Okay, so if I want to show you this in Excel, that would be a good way to explain this rank. uh, yeah, so guys, can you see the Excel? Hello. Guys, am I audible? There's some internet issue here. Okay, okay, you can see the Excel, right? Okay, fine. Yeah, so check here. Let me take the same example, and then so we are specifically talking about sort function. We are talking about order function, and then we are talking about rank function. So these three are the crucial function in terms of like when we work in data frame and all. Okay. So now I'll take one example. The same example. Let me take the same example. Okay. So I have 10. I have 20. I have 30. Then I have 5, then I have 12, then I have 15. So this is my example. Let me delete this. Fine. Now, if I sort this, so sort will be simply what? So this is my normal vector. Now I'll sort it. Okay. So sort it in, by default, it will be in ascending order. So I'll copy the same thing here and sort it using, we have sort function right here, smallest to the largest, ascending order. Sort it. I'll just sort this. Fine. So this is my sorted matrix, sorted vector. So sort is done. So what order does is, okay, order, if you go back here, basically order gives you the it displays the indices of the sorted object. Okay, so what it does is it displays the indices, as I said you. So 5 is your first element after sorting. Okay, what is the index of 5? So index of 5 is 4. So basically, if you go back to Excel, so this is my index. Let's create a column called index. Okay, this is my first index, second, third, fourth, fifth, sixth. I have 6 element. So order will give me index of 5. So what is my index of 5 is 4, right? Index of 10. Index of 10 is 1. 12, it's the index of 12 is 5. Index of 15 is 6. Index of 20 is 2. Index of 30 is 3. This is the output of your order command, order function. Okay. Now, what rank does is rank takes your normal vector, okay, it orders it, okay, and assign number, I mean like 1 2 3 4 5 to that. So now after sorting, 10 will be this is after sorting, this is your output, this is your sorted output. Okay, so 10 will be assigned, I mean like 10, like which will be the first element, your 10. Okay, if you sort it, so each element will be assigned a number in sorted vector. Okay, so 5 will be, just check here once. Okay, so if I apply rank, okay, so it gives me 2. Why? Because 2 is my second element. Okay, fifth, no, 1 minute. Okay, so let's take here. So we also have rank function in Excel. Okay, so let's forget about Excel. Let's check it here. Rank. Okay, so what rank will do now? This is your normal matrix. Okay, normal vector. So this is the first element. So here this will be assigned 1. Okay, and which is my second element will be 10. So this will be assigned 2. Okay, which will be my third element? 12. 12 will be assigned 3. Which is my fourth element? Here will be fourth element will be 15. 15 will be 4, and then 20 is your fifth element, and then followed by sixth element 30. So this will be your output of the rank. Guys, are you clear here? Because it's important. So like it's a little confusing at times. I also get confused. So that's why I'm showing it separately in Excel so that you understand related. Is it okay? Sort, order, and rank. If you want me to repeat anything, just ping me here. I'll repeat it. Ping me in chat that if you want something to be clarified again, I'm okay to do that. Anyone? Sanchita, Mama, Madhura, any questions? Ritushri. Okay, so there's one question. Uh, so the request is to repeat the rank function. Fine. So I was expecting here. Yeah. So yeah, correct. So rank is a little confusing, but the reason I'm doing it in Excel to make you understand what the concept is. So you are okay with sort, you are okay with order. Okay. So sort is sorting the original element itself. Order is sorting the index of the element. This is clear. This is original element. item, for example, and this is the index of the item. Index of the item. Fine. Now, when I'm talking about rank, so rank is basically, it is a combination of this. What it does is it takes the original vector. Okay, in original vector, it goes in ascending order, and in ascending order, it starts ranking 1, 2, 3, 4 to the elements. Okay, ascending order means like the first will be the smallest element. So it will search in the vector which is the smallest element. So it will see that 5 is my smallest element. Okay, it will assign 5 1. Okay, now it will search for the second smallest element, that is 10. It will assign 10 value of 2. It will search for third element, so third element will be 12, so 12 will be assigned 3. Okay, then fourth element will be 15, it will assign 4. Okay, and followed by 20 and 30, 5 and 6. So this is what rank does. So if you see the output, go to R, run any vector. So this is my vector. I run rank in this. So what it does is, this is my original vector, and then I run a rank here. So this is my original vector. Okay, and then I run a rank here, right? So what it does is, it goes, it checks the like my, what is the first element, this gives 2 here. So it, if the, like 2, because like first element is 5, the smallest element, so it assigns 1 to smallest element. Then like 10 is my second smallest element, so it assigns 2 to it. Okay, then your third will be 12, so 12 is 3. So likewise, it assigns the indices, like numbers to the each element based on your sequence or ascending order. Okay, now how can you relate this? Basically, if you just do it in R and try and understand it, it is a little confusing. So try and understand it in Excel. It's far easy to understand here, right? So this is the output you got. If you copy this and paste it here, okay, this is the output you got, right? 2, 5, 6, 1, 3, 4. Exactly what we did in Excel, and this is the output you got, right? Fine. So this is it. Now let's do one thing. This was our 3 main functions that I missed somehow, and let's start with actual subsetting, which is our agenda for discussion today, right? So guys, to go ahead, like what we'll do is, since we start with data frame, so uh, we we have 2 options: either take the default data set that we have it in R, okay, or import a uh, data set into R. Okay, so small features like that, I want to cover now itself before we get into actual subsetting. Okay, that is import and export. Import and export in R. Okay, so I have done it earlier as well, but let's take one example now. Okay, I'm trying to use the interface. I'm trying to use the import dataset function. Okay, I'll import this, import CSV. I'll browse and go to workshop. Where is the R script? We have data. Workshop. Okay, so I'll take Facebook example. I'll take a Facebook dataset. Okay, so it's a tab, limited tab. Okay, so this is my Facebook dataset. I'll import it. Okay, so this is how it looks like. So let's explore the data set, then we'll use subsetting in this only, right? So we have, for each profile, for each Facebook user, we have user ID. Okay, for each Facebook user we have a user ID, we have user age. Okay, and then we have date of birth day, then year, then month. You have gender, we have tenure. So tenure is in day, right? So since how long the, like, this person, this guy is there in a Facebook. Okay, and he's just 14 years old, so he's from 266 days he's in Facebook. So how many friends he has, how many like friendship he's initiated, how many like he has got, on how many people likes he received. Okay, mobile likes. Okay, mobile likes received, all those things. So we have few columns here, which makes sense once we read it, and then we'll explore this data. Okay, I'll just go back. So this is the importing done by this is the import. Now let's say I have imported this data set. This is Facebook. I This is the import thing, right? Import is directly done using your import data set option, right? This import data set. Fine. So at times, not at times, always, you need to export your analysis, like at least a summary thing, like whatever summary, whatever analysis you have done, whatever model output you have, that you might need to export it to your local system to make presentation or to share it with somebody. So that is called export. So anything that you export from R will be covered in export function, right? So import is like importing from the local or the server. Exporting is you're exporting it into your system, right? So in export we have a couple of options. So you can export data in various forms. So one of the, like, most commonly used forms are CSV. Okay, CSV2. Then you have table. You can delimited character line CSV, whatever delimit. Okay, so I'll try to write it in SP. So write.csv. So basically what it will do is it will write your data set to your local system from R. Okay. So what is the parameter it accepts? So you can even look the document of write.csv, but I'll just briefly explain you. So it accepts the object you want to write. Okay, so my object, let's say the object which I have imported called Facebook, right? So let's write the Facebook back to my local system. Okay, with different name. So this is my object that I want to write. Okay, first thing. Second thing is, like, by what name you want to write. Okay, by what name. So let's say demo CU, like CU class, right? So dot, and this dot is very compulsory. I mean, dot extension is very compulsory in which format you want to write your data set. Okay, in your local system. So let's say since I'm writing write.csv, I'll use cu class .csv. Okay, and I have not given any path. I have just given the object. I have just given the file name which I want to which I want this file to be renamed in. Okay, now the question from your side should be like where it will write it. Okay, so as I told you earlier, R works in like directory concepts, like which directory it is working in. Okay, so I'll check my working directory, get my working directory. I'll check my directory, and my directory is this. So what R will do is basically when you write this command here, it will go to this path, and it's somewhere here in this place. It will write the uh, uh, data. So now let's check it, because now you don't have anything from CU. Here, nothing is there with the name of CU, right? But once you write it, so it will be visible here. So let me write it, write.csv. It took some time, and then if you come back here, you'll see uh, cu dot, you have a file here. Okay, this is your file. So what it did is, where it went. I wrote it, right? Where it went. Okay, yeah, it's here. So it wrote it here. This is your file. Fine. So this is called export. So this is a very small topic, but it's very handy and very useful most of the time, right? So write.csv. Fine. Okay. So now let's go back in subsetting. We'll for few examples we'll use Facebook. That's the reason I've imported it here. Okay. But let's start with subsetting, and we'll use the default base package. So whatever the default package we have, we call it a default package, which comes with installation of R, or we call it base package as well, base package of R, package of R, okay, for subsetting, right? So let me comment this now. Let's figure out. Let's take some data. I'll take empty cars, which is a default data set, and empty cars has this many variables. You have this many variables here. Okay, this is my data set, which is there already in R. Now I'll use some logics to filter out and all those stuffs, right? So in empty cars, let's say I want to check all the uh, cars which have gear, which have four gear. Okay, four gear. So let me check how do we do that. Okay, so let's forget about what is written now. Let's check the class first. Okay, so we need to work in data frame. It should be a data frame, then only we can use it. Okay, so it is a data frame. First thing is done. Now what is my question? My question is like I want to filter all my uh, like data of which is having gear, only four gears, okay, in the car, which is a like features of a car. Okay, how many rows it has in total? Empty cars, empty car has around 32 rows. Okay, let me do that. So I want to filter out empty cars. I'll give a third bracket. So any subsetting will have an will always happen inside the square bracket. Any subsetting for that matter. Okay. So first step is like your data frame. This is your data frame. Okay, and the square bracket. Okay, inside the square bracket, you'll write the logic. I mean, like you'll write the filtering condition. So my first filtering condition is I want empty cars dollar gear. Gear is equal to 4. This is my condition, right? I want all the rows, okay, which is having gear 4 as values 4. Okay, in column I don't want anything, just write column, a comma, and leave it, because again this is a data frame and it works on the concept of row comma column. So there is no filter on columns. Obviously we cannot like uh, write filters on column, right? Either we select it or we deselect it. So I left it as it is. So that means I want all the columns. So let's run it and check it. Yeah. So I got an output and the output looks like this. So I have out of 32 models, I'm getting all the models which is having 4 gear. Check here. Okay. I have only 4 gears as option. Earlier I had 4 gear, 3 gear as well. Okay. So I have only 4 gear option. Fine. This is one thing. Now there can be multiple combinations like based on your need. So now what you want, along with 4 gear of 4 gears, you also want all the cars who is having horsepower more than 100. This is your second condition. So let's write a condition. So again, that is a filter on the rows. So I'll write and HP, horsepower, greater than equal to, let's write only greater than 100. Okay, and in rows again it will remain as it is, no filter. So let's run this. HP not found, sorry. So HP, we cannot write it directly, we'd have to write, because I'm using base function, okay, of R. There is no package which is needed. So I'll just write empty cars dollar HP, right? And then run it. So now what I got is like the rows has been reduced as compared to the rows which we got earlier. We got so many rows earlier. Okay, from 32 we got this many rows selected. Now second is like if I'm putting one more filter, gear 4 and a horsepower greater than 100. Okay, so I got horsepower greater than 100 all the cars. So I just got 5 rows. So there are only 5 cars in the total data set which matches this condition of gear is equal to 4 and horsepower greater than 100. Right, guys? Are you with me? Able to follow? Guys, any questions? Put it in chat. Put it in chat if you have any question. Yes, no, understood, not understood, confused. Anything? No? Do you want me to repeat it or something? Okay, fine, Shubham. Fine, so let's go ahead. Okay, this was one example. There are multiple combinations that you can generate. Okay, just try and play with the default dataset in R. Okay, and uh, put filters based on your need. So let's take one example from Facebook dataset that I have imported. Okay, so my Facebook dataset. I have seen the dataset. So what my requirement is, I want all the percent. So first of all, let me take the count of how many rows I have. So it should be a decent size data set. So I have around 9,000. I have 99,000 rows. So like it has 1 lakh rows. It's a big data set. Okay, 1 lakh rows. Now I want all the data, all the person. Like I'll see the how many male, how many users are male and how many users are female. Okay, so let's use it. Let's do it. Let me just take a sorry let me create a filter frame. So Facebook dollar, I want gender, right? So my gender is equal to male. So let me check the caps, how the male and okay, it's in normal caps, small caps. This is my male. So let fb let me put it in a variable called fb male, right? And so there will be one error if I don't do it. I just need to put comma because I just need a I'm filtering on rows. Column is as it is. I'm not touching it. Okay, so run this, and the similarly we'll do it for female as well. And then we'll see how many male we have, how many male user we have, and how many female user we have. Fine. So female is written how? Female normally, right? So female. Okay. Now take the count of male and FB male, FB female. So we have out of 1 lakh, we have 58,000 as male. Okay. And we have a remaining user definitely will be your 40,200 something is your female. So guys, I got a clear picture of my data set that this is my distribution based on gender, right? Now let's go one step ahead and do something. I want all the user who is born post 2000. So post 2000. Okay. So I want all my 21st century users. So what I'll do is I want, so I now I'll do it directly. Okay. I'll write everything in a go. So I want all the users, Facebook. Okay. Facebook, dollar, year, date of birth, year. Okay. Greater than equal to 2000. Okay. This is my requirement. Now let's see how many users we have. So comma, I want all the rows of 2000 and greater, and all the column, no filters on column. Okay. I don't want to save it in a different object and then take a row count. What I'll do is I'll put this entire thing under row count. I can do that. Okay. And row. So what I'll do, I'll directly get the count of the user without creating a third variable. So let's run this. So I get out of 1 lakh user, I have only 484 user who are 2000 and greater date of year, date of birth year, right? That's clear. Okay. now. Okay, great. So let's move ahead. Let's see a couple of example in empty car. So just you have AND operator which you can use. Then you have OR operator if you want OR operator. So here if I want to check how OR operator works, right? So I can check it like this way. Let's say I want all the users who are post 2000 born, post 2000 born, or all the users, all the users who all the users who is let's say 14 years greater than 14 years of age. Okay, for 15 years of age, greater than 15 years of age. Okay, my second filter will be Facebook, age greater than equal to 15. This is my second filter. Guys, is it clear to you now? Then I'll put a comma because this is my row and I don't want any filters on column. Is it clear to you? I'm putting on two filters. I'm putting a first filter on date of birth and then second filter on age, right? Let's run this and check how does it look. What is the issue? Facebook. Oh, sorry. So this bracket will be here. Okay. Okay. So I have 97,000 users who are born post 2000 or who is of more than 15 years of age. Okay. This number looks huge, but yeah, this is it. Okay. So this is multiple filters in data frame. How about multiple filters you can put? Okay. Okay. So this entire filters logic. So whatever filters we put, whatever logic we put it inside. So this again follows the same uh, law or a rule of math called your BODMAS. Okay. So BODMAS is basically, a minute. Okay. So this BODMAS, bracket open, division, multiplication, addition, and subtraction. Okay. So this exactly follows this filter condition, the logic inside. If you have multiple things inside, okay. So let's say I have OR, and then I also have AND operation inside. Okay, where Facebook uh, gender is male. Okay. So what will happen? So this AND will be given precedence, like law of precedence and what it has. So similar thing will be applied here. So all and so if you want two operations to be done on the given a precedence or the importance first, so you need to specify those in a bracket. Okay, so I'll send a document to you so that covers rule of precedence and how does it work in R. So can you just go through that? It's a very clear, clearly specified there. Okay. Okay. So this is it in basics of subsetting. So let's go ahead and I'll just write down the basic operator that we have. Okay, so that you can recall it. So we have AND, we have OR, we have not equal to. Okay, so exclamation is not always in R, not equal to. Then we have greater than, is less than, greater than, equal to, less than, equal to, whatever. Okay, it goes on. Okay, so this will be there. Fine. So okay, so guys, spare 2 minutes, think about it. Okay, and I'll just pause the recording, spare 2 minutes and think about it. Like if you have, fine, thanks to remind me, mama. Okay, yeah, so yeah, so we were talking about which operator. So which operator is basically used in places where I want to verify, okay, my filters. Okay, it is a logical operator in the first place. Now how do we use it, which operator? So if you just go to the documents of which, so it will tell you that it generate based on the logic that you have written. First of all, whatever the logic you have written, it generates a logical operator, and based on that logical operator, it fetches out the true and leaves the false beside. Okay, it leaves the false behind. So that is what it says. Give the true indices of logical object. Now, what is true for me? Here, true for me is any car model which satisfied both the condition, that will be true for me, and which don't satisfy the two conditions, that is false for me. Okay, so which will do, it will give you the index number of all the items, all the rows which satisfies these conditions. I mean, like whichever rows which is true for this condition, you'll get the indices of that row. Let's run this, okay, and check it. So it says index number 1, 2, 10, and 11. These are the indices where these two conditions were true. Now let's verify it. Okay, that is the most important thing. So what is my condition? My condition is cylinder is equal to 6 and gear is equal to 4. This is my condition, right? Okay, so let's see. It says first element. So go to the first element. Okay, first element is this. Let's verify if it satisfies the condition. So gear is equal to 3. Okay, and it's a and thing, right? Gear is equal to 4, it says, but this is wrong. Okay, so it gives you, and let's see what is the cylinder is 6. Okay, and gear should, because I'm applying and here, it should be uh, false. It should not give me 1. Let's check some other example. 2 is cylinder is 6. Okay, sorry. Okay, fine. So basically I'm seeing the filtered data. Let me see the original data. That's the reason. So let me see the original data. This is my original data, right? This is my original data, and the output of which is this. So now let's verify it. Guys, you got the point that the earlier which when we were seeing, so that was filtered data where empty gear is equal to 3. So I have all the entries of 3. That's the reason. Now let's see the original data and the output. So if is how which is working. Okay. So which cylinder is 6? So cylinder is 6. Okay, because 1 is my output, so I'm verifying the first row. And gear is 4. So gear is 4. So this is true. Okay, and if it is true, which will give the index number of this row. Okay, then let's go to 2. 2 is again cylinder is 6, which is matching, and gear is 4, which is also again matching. So first and 2 is your output. Third is cylinder is 4, but that is not the requirement. I want cylinder is equal to 6. So this will be discarded. In fourth, you have cylinder 6, but the gear is 3, but my requirement is gear is equal to 4. So likewise, it will check each row, and if whichever rows turns out to be true, it will return the indices of that row. So this is what it says. Only 4 rows matches the logic of matches this logic. Guys, how is it going? Like, is it clear to you now? Okay, fine. So let's check it. Okay, now let's move ahead and check some examples. Okay, of column filtering. So we saw the base packages and how it is used for filtering rows, right? So this is my ways of filtering rows, putting in a logical operator on the left side of the column to filter my rows, right? Now, as I said, data frame in R or in any, like if you future, if you plan to learn Python, okay, so in Python as well, so data frame always have this row comma column concept. So whatever you write on the left side of the comma, it is row, as considered as row operation. Whatever you write on the right side of the column, this is considered as your column operation, right? So we filtered row in many examples above. We filtered row by putting in lots of operator and logics. Now what is left is column filtering. Like column filtering is this is the filtering. Okay, so what we do is, let's take again same example of empty cars. I want all the rows. I don't want any filters on rows. Okay, but in column, I just want I would just want a cylinder column. Okay, so cylinder column, you put it in bracket. Okay, so you'll get all the rows on and only cylinder column. Okay, now if you wish to have multiple columns in your filters in your new data set for that example, okay, so you just create a combine it using C, okay, and kind of create a vector. Okay, so you want cylinder, you also want number of gears. Okay, put it here. Fine, put it in a bracket and then run it. So I see all the data with only two columns. Okay, is it clear, guys? Right now, the logic, I mean, like the example goes on and on. You put something on the right side on putting filtering rows. So I want all the rows where the empty car cylinder values is less than equal to let's say less than equal to 5. Okay, and only two columns. So I have put on I put the filters on number of cylinders, that is on rows. I've also put on filters on column. I was just want two columns and all the rows which is less than equal to 5 in terms of cylinder. Run this. So this is my output. So you see here I have all the cylinder which is less than equal to 5. So the 4 is the only option, and your two columns. So gear and cylinder and gear. Fine, guys. So we use it in this way. Then which operator we have seen? Which operator basically returns you the indices of the element, right? Uh, go ahead. Let's go ahead. Let's go ahead. Selecting columns we have seen. So how do we select column? If we have single column, just put it in a quote after column after this comma. And if you have multiple columns that you want to select, so put it in a vector form like this, right? Okay, now fine. So now let's go ahead and so this example we have seen selecting and subsetting where we are putting filters on the row like what we saw earlier, and we are also putting filters on column, right? Okay, fine. So we saw filtering, we saw your indices, order, sort, rank, everything. Now there will be a situation, I mean, like again and again, where you have this data set empty cars. Okay, this is your data set. This looks like how this looks like. Put it here. So if I paste it, so this is my empty car data set. So what I want is I want to create one column, okay, which will tell me which is a simple. I want to calculate. I want to multiply gear and carb, okay, and create another variable which will have the multiplication of gear and carb. Okay, what I'll do is basically if I were to just select it, so I will let me do it here. So do it here. Okay, let me yeah. So what I'll do is like I'll create a variable. Let's say x. I'll create a variable x, or let's say empty car new columns. That will be easy to understand. New empty car new column. Okay. So what it will be? So I want empty car gear, and I want to multiply that with empty car carb. Okay, carb. So this is my calculation. So I'm doing a calculation to create a new column. Okay, and then let's run this. So this is my your new column. This is how it looks. Okay, now if I want to add this into the data frame, guys, so just like trying to understand like what it is. So I have this my new data. I have my this data set which is by default in R. Okay, let's put it in a variable called x. Yeah, empty cars. Okay, then from empty car I've created a calculated field by multiplying gear and carb, okay, which lies in empty car new column. Now what I want to do, I want to see this this is like how many columns, 2 4 6 8 10 11 columns in your old data set, and one column that you have created here in new column. So this total 9 column, you want to see it in one data frame. So what I'll do is I can simply do C bind because I want to bind the column. Okay, C bind my old data set. Okay, I mean like the calculated data set and the X, like which I've created. So X comma, I mean the old data set comma new column. So just bind it. Now what you see is this. You have a something like this. So this was your old columns till carb. If you remember, if you go back and check it here, you have till carbs, right? Carb. Now what I did is I created a new column called empty new call, which is a multiplication of these two. You're getting is it making sense, guys? I've just created a new column from the base package, and what I did is I simply multiplied two column and took it in a new variable. Okay, so this is called your data table manipulation. Okay, you are manipulating the table, you are manipulating the data, you are trying to create new variables, right? Amazing, fine. So all this what we have seen so far was a bare base package of R. Like we did it simply using a base package of R. Now we have seen in this example we created new column. Okay, we have seen order. Okay, so ordering, ascending order. And now by default, as I said you guys earlier, that by default any sort ordering operation happens in ascending order, right? If you order cylinder, so what it shows it like it is doing it in for each thing. This is index, right? So let's do sorting first. So it happens in your ascending order, right? Small to big, ascending order. But if you want to reverse it, so there is a provision of reversing it. So simply you just need to pass a parameter which is says decreasing. You put tab decreasing is equal to true, right? So decreasing is equal to false is your default behavior of R. So this is by default which you get. The one which you got here is the default behavior, right? So see here, these two are same. So by default, decreasing is always equal to false. But if you want to change it somehow, if you want it in ascending order, let's say descending order, sorry, already ascending order is there, descending order you want it. So you just need to make it true. You can write only T, or in caps you can write true. Okay, and you run this, so you get a reverse order. Okay, so this parameter of decreasing is important. Okay, in which like in relation to the format you want it in ascending order or descending order. Okay, so fine. Now one very important thing, and at the beginning it will be a confusing thing as well, you will be a little confused now. Okay, but yeah, it's okay because you need to understand it's very important, okay, to work with the data. Now for data understanding, so since we are talking about data wrangling and trying to understand the data, okay, so most of the time you end up grouping your data. Okay, grouping and aggregating, which is most commonly used. Aggregating to understand like what actually is the data, what sense does it make. Okay, so let me again come back to SQL and create one small scenario for you so that you understand what actually this is, right? Group. So let me write group by, group, group by. Okay, so what happens, let's say there are a company, you have a company, you have let's say age, employee age, then you have employee age, then you have let's say salary, average salary, uh, salary, because individually what it will be average. So let's say TCS, employee age is 28. Okay, employee salary, let's say 100K. right? So you have something from you have Google, average age is 29, and salary is 200K, right? Then you have a lot of companies here. Uh, let's say you have CTS. Okay, you have average age of employees 26, and you have salary of 80K. Okay, then you have let's say a fine analytics. Average age is 25, and salary is, let's say, 90K. Hmm? Then I'll put one example of TCS. Okay, you have averages of 24, salary is 85K. This is my data. This is my entire data structure now for this example, right? I'll make it bold. I'll put it in center. I will even give a good, better look and feel to understand, so that you are understanding it. Fine. So what happens now? Basically, this is what, like, somehow the data looks like. Now, group by, what it does is, like, when I say group it, I want the average age of teachers employee, okay, or an average age of CTS employee, or whatever. Okay, so I need to group it. Okay, and basically I'm trying to roll up. So there's two concepts called roll up and roll down. Roll down. Okay, so what does it mean, roll up and roll down? So roll up is basically, you are, this is a transaction, right? This is one transaction, two transaction, three, four, five. You have five transaction. So this is a transactional data. Okay, let's assume it. Now if you want to roll up, that means you are using this data to go one step ahead. Okay, one step up, roll up. Okay, so what I'm trying to do is, like, I'm trying to group the company and then aggregate these numbers. So what my target is, so each company once. So my target is to have something like this. So I'm rolling up on company. So I'll no more have a two TCS. So if I roll, I just sum it. Roll up by sum. Roll up by sum. Okay. So what will happen? Both the ages of TCS employee, this plus this, will be added. Okay, and other sorry. So this will be added with this. Okay, Google will be as it is. It will come directly from here, because Google was just once. CTS was also just once, so it will come exactly from here as it is. A fine was also one, so it will come directly from here. Now in TCS, again, your since I have added it, my aggregation was sum. So TCS salary, both the salary will also get added. This will be added with this. Okay, so addition does not make sense. Let's call it a average or mean. AVG, average. Average. Number one is 1000. Okay, I have given K here, right? So it is not accepting K. Let me remove all K from here. So this, since average and all accepts only numbers, so I have given K, so it is getting confused. Okay, so my average is average salary of TCS is 92K, and let's work on the your age as well. So my average age will be, if I roll up of TCS, will be your 25 and 28 average. So this will be my your average of TCS. So remaining, since it occurs only once, so remaining will be as it is. Google will be as it is. CTS will be as it is. Yeah, fine will be as it is. No changes, right? Same goes for salary as well. See, Google only occurs once, so no changes. CTS also occurs once, no changes. And your fine also occurs once, so no changes. Now, what I did is I just rolled up my data on company employee. So now I have unique employees, one employee, one company occurring once, and I have aggregated data. So aggregate means your mean, sum, okay. This is your aggregation count. Such operation will be aggregate. You'll will when we start basics of SQL, so you'll know a lot about it. But this is your aggregation. So now this is what I'm trying to achieve in my R. Okay, I want to group it by company and do some operation like mean, average, sum. Okay, now how do we do that in R? So guys, are you clear with what I did? Okay, I'm rolling up. So now if similarly, if I have some data where we have a provision of rolling down, so I'll go and expand it. So expanding means like based on company, I'll expand it. And rolling up means like I'll roll up, I mean, I will make each company unique and I'll do some aggregation on numbers. Right? So now let's go back to R and understand how does group work in R. So I have written a code here. So when I'm talking about your base package, the default R packages that R has, so we have a function called aggregate. Okay, when we use a package called dplyr, if there you want to aggregate and do some operations for aggregation, so there we have a function called group by. Okay, so let's see aggregate now. This is my aggregate. Okay, so I'll write aggregate. You can even read about aggregate, it will help you. Okay, I'll write aggregate. I'll give my column on which I want to like which the column which I want to aggregate first of all. So I want to give such columns, all integers which I want to aggregate, average it out, sum it out. So this will be my that column, my number column which I want to aggregate. Okay, then comma by means like on which label you want to aggregate. So here in this example I was trying to aggregate on company. Okay, so I want to in by I'll give that variable name or column name on which I want to aggregate. So gear is what I want to aggregate. Okay, now what function you want to use, sum, mean, average, multiplication. So I want to sum those. Okay, so let's run this. So first you have seen the data, let's open the data once again. So this is the data. Okay, so what I'm actually looking for is I want to sum carb. So this is my carb. I want to sum carb. Okay, based on gear. So all the 4 gear model will be summed together. All the 3 gear cars will be summed together. Okay, this is how it will work. So let's run this. Now check it. So all the three gear car summed it. The car value is 40 because I'm summing it. Okay, for all the 4 gear, the sum value is 28. All the 5th gear, sum value is 22. Okay, the similar function, if you do it and write mean here. Okay, so let's try this. Let's try it here. Check here. So similarly, exactly same thing happened. I just grouped based on gear and I did an average of the carb. Okay, and this is my output. So this is how the aggregate works. So aggregation is very important. Okay, for long-term use of R. So it is like you'll use it. You'll use this function almost every now and then once you start working in R, right? Okay, so this was a T apply. I'll leave it for now. I'll explain you later on. Okay, and then you have we have seen group by. Okay, so let's take some more example of group by, and I'll tell you how to do it in an easy way. Okay, we use aggregate here, we use group by and dplyr. Okay, we also have a small table function called table, which will give you similar result. Okay, but in some places, not always, but in some places it is useful. Okay, so let's take one more example. What I want to do is I want to group my data on number of cylinders. Okay, and to I want to check the average displacement. So I want to check average displacement of of all the car models based on cylinder. If a car, what is the average displacement of cylinder 6 model car? Okay, let's do it. So guys, you got the question right. So I want to aggregate my data based on cylinder and take the mean of my displacement. So let's aggregate it. Aggregate empty car. Okay, comma. So I want to, sorry, I want to aggregate it on my cylinder value, right? Cylinder by, okay, by what I wanted. I wanted it to happen in list. Okay, I wanted to group it by cylinder, right? Sorry, this will be your displacement. So what I want to do, this is displacement, and by your empty car is your cylinder, by cylinder, right? So what I want to do is I want to find the mean. Okay, let's run this, check what the output looks like. Okay, so argument x is missing without what is this? List displacement. Okay, so mean will be without bracket. Okay, so let's run this. Okay, so now you see in my this like cylinder. So I have 3 different cylinder, 4, 6, and 8. All the car models has this many cylinders. Either it will be 4-cylinder cars, it will be 6-cylinder car, it will be 8-cylinder car. Okay, the average displacement of all the 4 gear car, 4-cylinder car is this 105. The average displacement of all the cars with 6 cylinders is 183. Okay, this is how it looks like. So guys, is it clear? First of all, group by operation, uh, Sanchita, Madhura, Komal, are you able to relate what I'm telling you and what we see in the screen, or are you, do you have any questions? Okay, perfect, perfect, fine. So perfect. So let's go ahead. So we have seen aggregate function. Now this is what I was talking about, table function. Okay, so now what I want to see is like for each cylinder, okay, what is the gear? So it gives you a cross matrix. Okay, so basically it gives you a cross matrix. Just run this. So it will give you cylinder on the rows and gear on the column. You have cylinder 4, 6, 8, and 3, 4, 5 is your gear. Now it gives you we have in my data set there are 1 car which is having 4-cylinder and 3 gear. Okay, likewise you can understand. So this is how it looks like. Fine. So this was basically all we have in terms of subsetting data, filtering data, group by, aggregate. Okay, without using any package. I mean with the R based packages, because I have not installed any package to run all this function. And in you will use it a lot. You will definitely use it a lot because it's very important. Now, my second thing, the second agenda for discussion was dplyr, as I mentioned earlier, right? So, guys, dplyr, when you hit the floor or when you start working or do some internship on data science, dplyr is something which you will use a lot. I mean, a lot. Okay. So quickly, let's get into the nitty gritty of it. Dplyr will we'll have to install it separately. It's a big package. So we call it like this, dplyr, dplyr. Okay, this will be your package name. Okay, when you install it, do one extra step, that is like dependency is equal to true, because this table is again this package is something which comes with a lot of other packages which is dependent on like this R dplyr is dependent on those packages. So if you do deep dependency is equal to true, so it will install all the packages which dplyr needs to execute first thing. Okay, once you install it, it will take time. It's a big package. Just bring it in the session dplyr, right? Once you bring that in session, so you are ready to use it. Now dplyr majorly, I mean like if you divide dplyr, so it dplyr, the world of dplyr is full of six functions. You have those six functions that consist of dplyr. Okay, there are a lot of many things, small things, but this majorly six function is used a lot. So what are those six functions, which we'll see individually, and we'll see some lot of examples as well associated with each type. So first one is filter, and try to understand what each step does, each function does. So filter is basically uh, the row filters. Uh, Whatever I want to filter on rows, right? So I'll use filter function. Now select function is used for filtering your column. So if I want to, out of my 100 variables that I have, I just need to select 10. So I'll use uh, select function. Out of 1 million rows, I just want 200,000 rows. So I'll use filter. Okay. If I want to do some extra calculation, if you want to see exactly what I mean is something like this. If I want to create a new column or a new variable based on the variables which is present in the data, we'll use mutate function. Okay, we'll use mutate function. To arrange your data set in any shape, any form, okay, we use arrange function. Okay. Now, in order to summarize your data, I mean like you summarize like count, group by, mean, sum, we use summarize function. And for group by, summarize and group by use alternatively. So and group by, so the aggregate function which you saw. So this is the whole dplyr, guys. So just to break a big thing into small steps and try to make you understand, so that your learning becomes easy, right? So this is the six functions that we'll see extensively. Let's start with few of those. Okay, let's see where we reach. So for the entire dplyr thing, I was doing this like some hands-on on the air quality data. Okay, so you can even try this air quality data. It's again a default package, default like data set in R. Okay, so if you want to see the default data set, what are the default data set you have in R, and if you want to explore it, so write data set, data set, right? And you'll be popped up with this data sets colon. Enter this, and the moment you enter, you'll get list of all the tables that are, I mean, data tables which are present in R, which you can use it directly, okay, in R without importing anything. So have a look into this once. For that example, I have taken the air quality, which is again a part of data set. This is not like I've imported from somewhere. It's a part of your data set. First thing. So let's view it. We have already viewed it. So column, what you have in column, you have around 6 columns: ozone, solar R, wind, temp, month, and day. Okay, this is your column name. So let's have a look into the data. This is how the data looks like. So you have a lot of NAs, okay, not available numbers. You have integer number, you have a integer number, you have a float number. I mean the double or decimal number, and you have integers. It's all the integers. Okay, guys. Now let's use uh, filter function. Now let's start using dplyr. So once we install dplyr, so this six function will automatically come into your uh, uh, box. Okay. So I think let's do one thing. Like tomorrow, let's connect tomorrow in the morning. Okay, and because this will take time, if I start, I need to cover all. Okay, we have 5 examples, so I need to cover them all. So it's late. Let's do it tomorrow, guys. Tomorrow in the morning.